actually creating a lot of merge headache for yourself by having that feature branch in place. But that's not the only downside to that approach. The second negative of using branching in this way is it discourages opportunistic refactoring. So in an Agile project, if you're coding along and you realize that the customer class is misspelled, you should just change it and fix what's called a broken window in the Agile world. But if you're living on a feature branch, that's a hassle, because if you change it on the branch, then that's really going to make your merge conflict worse. But now you've got to get off the branch and fix it, and then go back to the branch and pull, and there's just so much friction that you'll just end up not doing it. And so it discourages the kinds of things that you'd really like to encourage as much as possible in projects. The third problem is it's really hard to combine things that are on feature branches in an ad hoc way. So, for example, if the big boss comes by and says, okay, I want to see mainline plus plum, mainline plus green, and mainline plus plum and green. Well, now you've got to do all these merges and get all these things working together. And if the boss comes back next week and wants to see the same thing, you've got to redo all those merges and all that other stuff again to be able to show them that. So it's really hard to see in an easy way the combination of features that you have in flight without a whole bunch of merging and other sorts of headaches. And so using something like feature toggles, and I'll talk more about the syntax of this and some of the pros and cons of that in just a second. Using feature toggles means that everybody stays on trunk or mainline all the time. Professor Plum creates a feature toggle for his features. Reverend Green does the same thing, and they keep each other's feature toggles turned off. There is no big scary merge because the merge happens real time. In fact, I will contend that there is no way to get fewer merge conflicts than by using feature toggles and staying on trunk. Because as soon as two people touch the same file, you get the merge conflict, not days or weeks later. And so the way to spend the absolute least amount of time possible dealing with merge conflicts on projects is to use feature toggles or feature flags like this. Refactoring is easy because you're on trunk all the time, so you just make changes outside of the feature flag and it becomes part of the code base. Combining features is trivial. You just turn on the feature flags and build the project. All the compilation and other issues have been resolved as you've been working on it over time. So those address the shortcomings of feature branching. What about the things that feature branching is good for, like cherry picking? Problem we just talked about before, where I have an in-flight feature that I might want to pick up. Well, feature toggles allow you to do that as well. Professor Plum, Reverend Green each create their own feature toggle, and you can manage in-flight features like that. What about teams that use branches for doing things like code reviews? What if you have junior developers and you want to code review their code on a branch before you promote it to trunk? Well, you could do the exact same thing with feature flags and just leave the flag turned off until you actually trust that code. If your junior developers are so bad that the code they produce won't even compile, you've got much bigger problems than whether you do code reviews on that particular code or not. Let's see. Are there measures for determining if two developers on trunk are working in a discontinuing fashion without interfering with each other? Are working in a discontinuous fashion without interfering with each other? You mean touching the same files? Is that what you mean? Well, in trunk-based development, you find out as soon as you both touch the same file, because you get a merge conflict, and you resolve those outside of your feature flag. I'll talk about states in just a second. Okay, and I'll talk about the release branch business as well. So let's talk about some practices here and some things to avoid and be careful about. There's a great resource here written by one of my former colleagues, Pete Hodson, on Martin Fowler's website. Martin does a lot of publishing of interesting articles these days on his website, and one of them is this really good coverage of feature toggles. In fact, Pete is working on a standard feature toggle syntax now, so that different feature toggle libraries can be interoperable with each other. So that's some interesting work that he has going on right now. So let's talk about some definitions for these things and some pros and cons. So here's the most basic possible version of feature toggle. Here's the before, where I have an online game that has this critical function called reticulate splines, and I want to try out a brand new algorithm for doing that. It's maybe more efficient or better resource usage or something like that. Here's the simplest possible feature toggle. I create a variable here that says use the new one true or false, and if use the new one as true, then return the new one, otherwise return the old one. Okay, well, this is very limited in that it only works within this particular method, but that's the essence of a feature toggle. These are written in JavaScript, because everybody knows JavaScript now. One of the advantages of this approach is that it's trivially easy to test both sides of the toggle, because now I just set the variable to one and then execute it, set the variable to the other, and execute it. This is a more common scenario where you have a toggle that touches more than one part of your code base, and you want to be able to make these dynamic. So all of the frameworks that I talk about that do this allow you to have what's called a toggle router that basically lets you have a single place where you define all your toggles and then be able to insert them within your code base at opportunistic locations. This allows you to choose on a case-by-case basis who sees the toggle and what state they see that toggle in. I'll show you some of the framework support for doing things like canary releasing and isolating toggles in just a second. This allows you to very easily determine who sees what when, and this is actually the secret to a lot of continuous deployment scenarios. One of the pieces of advice that we gave a few years ago, you may be familiar with the Forks Technology Radar, which is this publication that comes out twice a year. We actually just created a brand new radar last week in Barcelona, and it will be out in about 5 weeks from now. So we know what's going to be on it. We just got to write all the stuff up now. One of the pieces of advice we gave a few years ago on our radar is to do QA in production. Now, we're not suggesting that you turn your users into your QA staff, but if you can deploy your code into production underneath a feature toggle that only your QA has turned on, then you're doing QA in production. One of the things that a lot of companies struggle with is coming up with a realistic production-like environment. It turns out you have a realistic production-like environment called production. And using feature toggles like this allows you to get code into production as quickly as possible. Now, remember, one of the goals that I stated earlier with deployment pipelines is to get code into a production-like environment as quickly as possible, because all these intermediate environments are, at the end of the day, just busy work. Putting it in production is a great way to have a production-like environment, but then isolate that code so that only who you want to see it can see it. That's this idea of doing QA in production. And I'll show you the facilities on some of the feature toggle libraries that allow you to do this. As I mentioned before, I'm a consultant by trade, and it's extremely rare that as consultants we have the perfect solution to a particular problem. But there was a scenario that came up that turns out we did have a perfect solution to this problem. A client came to us and said, okay, they are delivering the software as a service, and they have a couple of really giant clients who really want their software to be as solid as possible. So they want fewer releases, but the releases have to be as solid as possible. They have 15 or 20 other smaller clients who want much faster releases and are a lot more tolerant of bugs and other things, growing pains, to be able to get faster releases. This company was just at loggerheads. We cannot figure out how to model this particular problem. And of course, the solution to this problem was two sets of feature flags, one for the more aggressive companies who didn't mind bugs, and then one for the larger companies. And basically what they were doing is letting the smaller companies do QA and beta test these new features and make them more solid for the bigger companies when it finally came around to that. So one of the few cases where it turns out there was a really, really good, suitable solution for a particular problem. So let's talk about some properties of feature flags around two different dimensions: longevity, how long do they last in your code base, and dynamism, how dynamic are these things? In other words, do they change every time you do a deployment, or do they actually look at contents of the request and make determinations based on who you are, what IP address, what location, what role, etc.? And I'll talk about 4 different kinds of feature toggles, but focus mostly on the experimental ones because they're the most interesting for what we're talking about here. One of these is types of feature toggles are release toggles. This answers the question about how you manage different release streams using feature toggles. A release toggle allows you to stay on trunk-based development, but exactly for the same reason you create release branches, you create release toggles to stabilize things that are getting ready for release. A lot of the feature toggle libraries will let you create nested or grouped toggles. So you can say, for example, that the October 22 release actually consists of these 4 feature flags, and it is itself a flag that you can turn them all on or off at one time, or you can turn them on and off individually. So this allows you to do the same kind of isolation, testing, and verification that you normally do in a release branch, but do it on a release feature toggle instead. And you can actually have multiple in-flight release toggles if you want, if you have a short-term and long-term release. So that's how you can manage different release cycles using these. Now, obviously, you have to take a little bit of care to make sure these don't get entangled with each other. More about that in just a second. You will, in this case, be releasing incomplete code paths, which made some of our customers really nervous, who wanted the benefits of being able to do continuous delivery and A/B testing and that kind of stuff, but realized that with feature flags that some code that hasn't been completed yet may get released underneath a feature flag where the feature is completely turned off. And we convinced them that, look, the if statement in Java always works. You never have to worry about it not working. And if you're worried about teams forgetting to wrap features in flags, in the feature flag, you can use the automated fitness functions that we talked about to validate, to make sure that, because most of the feature toggle libraries use annotations or attributes to tag the method that includes the feature flag, you can write an arc unit test that says make sure that all the code that's being checked in is within a method that has a feature flag definition or a particular feature flag definition. So I'll talk about GB's question here in just a second as well. So that's release toggles, the ability to do that. The next one that we'll spend a little more time on are experimental toggles. These allow you to do kind of A/B testing. Typically uses a toggle router and lets you determine what's on or off. And the typical lifetime for this is how long it takes to get useful information out of this experiment. So you're running an experiment to see if what your users like. And so that will determine the length and the life cycle of these. And these are highly dynamic. These typically change per request because this is exactly the scenario where you're just turning these on for A/B testing, half of them, or round robin or something like that. I'll show you the mechanism for that within the feature toggle library in a second. Another common kind of feature toggle, this is used heavily by Facebook, are operational toggles. These are toggles that operations uses that are not meant to be used by developers or even interact with developer toggles. These are things like either short-lived, we're migrating from one place to another and we want to hide the details behind some indirection here, or kill switches. Once we reach a certain capacity, we're going to switch over to caching instead of live updates, etc. And so those kind of things are often managed as feature toggles. And then the last of these are permission toggles. This is this idea of I want to release a free version of my software, and then if you'll pay me money, we'll turn on some additional cool features. That's just a product experience kind of thing, premium version. Turns out it's easier to create an entire piece of software and just turn features off than make it so that you can ad hocly add those things and make it work together. It's easier just to have it all working together and turn features off than get it to dynamically work together. And these are permanent parts of your code base. In fact, that's the real distinguishing factor of a lot of these. All three of the ones on the right probably look at some sort of either user information or something about your runtime configuration. So the operational toggles, for example, or experimental toggles. Whereas release toggles, they can change as your release changes because they are tied to the release, so they change with deployment. And the other big difference here is that the two at the bottom, release and experimental toggles, are ephemeral, go away after a period of time, whereas the other two are basically permanent features of your code base. Okay, so let's talk about some issues with experimental toggles and answer a few of the questions that have been accruing here. One of the best practices when you're using feature toggles like this is to remove them as soon as the feature decision is resolved. So when you put on your engineering hat and look at something like feature toggles, what you're really doing is adding purposeful technical debt to your project to be able to support things like continuous deployment and continuous delivery. But it is exactly that. It is purposeful technical debt, and you want to get rid of that technical debt as soon as it's no longer serving a useful purpose in your code base. One of the biggest negatives about feature toggles or feature flags, if you do a Google search for this, is you'll find a couple of pages worth of articles that basically read the exact same way here. That I used feature toggles one time, and it was one of the worst things I ever did in my whole entire life. But every one of these articles reads exactly the same way. We got super excited about feature toggles. We put them all over our code base, and now we're mad that somebody came and put feature toggles all over our code base because we're not cleaning them up, etc. So there are two different ways to make sure that you clean these things up when you're finished with them, because it's easy to just let them become technical debt, and of course they're making your code base way more complicated than it should be. One of them that we used to always do in the olden days when we did this was that every time we play a story card that has a feature toggle, we insert a downstream story card that says, clean up this feature toggle. We may not even know when that's going to happen yet, but we know that it's scheduled and it's now part of our backlog, and it's something that we need to address and take care of. So you can manage this from a process standpoint if you want, and every time you play one, make sure you play the symmetrical, get rid of it story card. The way we're more likely to handle this now is to create what is called a temporal fitness function. This is a fitness function with a time component that basically says, look, after a certain amount of time or after some objective criteria is met, you need to go and get rid of this feature toggle that you added here. So this can start as a warning and get more and more dire and become an error, etc. And so this is a great example of being able to create a fitness function that both verifies that code you're adding is underneath the feature toggle, but also a reminder to get rid of this thing when you're finally finished with it. Another best practice when using feature toggles, and this is true for feature branches too, it's just easier to deal with here, is don't go crazy with them, because every one of these you create you're creating a different testing path and different testing scenario. So you want to have a small number of in-flight feature toggles at any given time because it greatly increases your testing burden, because you're literally testing two different code bases here depending on the state of the toggle. This is also true for feature branching, but you almost never test the things on the branches because it's so difficult to test. At least here, testing is just a flip of the switch away, but of course that doesn't reduce the scope of the testing that you have to do to make that possible. Another best practice is don't create toggles that depend on other toggles, because this is the pathway to insanity. And so this is one of those things where you may have to reorganize the way you build features or take some other practices like this to make sure that you don't accidentally fall into this little nasty trap. Yep, exactly, MS. 2 to the nth is the number of toggles. So that's the argument that you want to keep the number of these things really small. These work everywhere. We haven't seen a technology stack yet that you couldn't get this to work on, because as long as it has a conditional, like an if statement, and can read from some sort of external configuration, you can wire up a feature toggle. There's this ancient development environment called Forte that we bumped into on one of our clients, and we figured out a way to implement feature toggles on top of Forte because it could read an external configuration file, and it had a conditional statement. But of course, it's way more sophisticated than that in almost every case, because there are tons and tons of libraries out there to help you do this in whatever platform or technology stack you're in. A good example of this, one of the really mature ones in the Java world, is ToggleZ, which has been around for a few decades now. This is a really commonly used feature toggle library in the Java world. One of the nice things about libraries like ToggleZ is that it uses annotations or attributes like this, depending on which one you're in, Java or .NET, depending on what you call these things. The nice thing about this, though, is it makes it really easy to clean them up. So the biggest dysfunction that you normally see with teams is they don't want to clean the things up when they're finished with them, because if you scatter them all around a large part of your code base, now you got to go chase them back down. Well, here's where this makes it a lot easier, because now within your IDE, you can say find usage of this label with this value, and now you have a list of all the places where that feature toggle shows up within your code base. So that makes it very easy to go clean these things up after the fact. Here's the activation strategy stuff that I was talking about before. That's activation by username, so you can limit this by username. You can also do by a client or server IP. So someone was asking me about feature flags have scopes. How do you turn it only for the QA team? Well, my guess is that your QA team is within a particular subnet of your network. And so you could either supply the usernames for your QA team or the range of IP addresses that only exist for your QA team. This is the way to make sure that it never leaks out. Is use the server IP of the servers or the client IP of the range of your subnet for that includes your QA. Put their client IPs here are the only possible IP addresses that can see these toggles turned on, and you can guarantee that it never leaks out. So that's how you control the scope of a lot of these things. You can also do it by username. For example, another option here is called a gradual rollout. That is known in the continuous delivery of the DevOps world as a canary release, where you have a large group of users and a large ecosystem, and you want to roll out some new feature without rolling it out to the entire user body. And so a canary release rolls this out to a small subset of your users. This is used to reduce the risk of release, because I'm rolling out some new thing that may have a huge performance or scale impact on my ecosystem. This is the way that you do multivariate or A/B testing, is to roll out this feature for some users but not for others, and then record their interactions as they use this feature. This is also the way to do things like performance testing and other sorts of operational worries. to make sure that things are operating the way you want them to. In fact, this is exactly the case study of how Facebook rolled out chat internationally. So they deployed all the chat code on all of their servers underneath a feature toggle, and then as the sunlight hit countries, they would turn that toggle on. So New Zealand got chat first, and then Australia. That allowed them to save the U.S. for last, so they could gradually roll this out and check what impact was happening on their infrastructure over time. This is the way that you typically roll these kind of behaviors out these days. So remember I said this works everywhere? As long as you can read from an external configuration and you have a conditional or if statement. But databases don't have either of those two things. So how do you create a toggle for something in a database? Because it doesn't take you very long to be able to need the ability to toggle a database as well, and in particular in this scenario. So I mentioned Pramod and this book earlier. Here it is, the Refactoring Databases book by Scott Ammer and Pramod Sadalge. And this is a common integration pattern listed in the Enterprise Integration Patterns book by Gerger Hope and Bobby Wolf, what they refer to as the shared database integration. So here's the scenario. I have 3 different applications. They all share the same data structure. So we decide, hey, why don't we just use the database as the integration point? Which sounds like a great idea until it's not. Because now I need to change application A, and that involves changing its schema as well. But B and C don't want that schema change. How do I manage to do that? So maybe I want to run a feature toggle on A, but B and C don't want to see that change. This is part of the move column refactoring. But a lot of these refactorings in this world have 2 different phases. They have an expand and contract phase. And so here's the initial scenario. A balance is over here on customer, and for application A, I'm doing a feature toggle which needs balance to be over here on account instead. But B and C don't want to see balance on account. They want it on customer. Part of this database refactoring is this transition phase. And in this transition phase, what I'm going to do is wire this up so I can support both schemas in parallel. There's balance on customer. I've added balance over here. And I've also created a synchronizing trigger that says anytime you add it to one, make sure it transactionally gets added to the other. I'm now living in a world where balance lives on both customer and account, and I can live in this dual world as long as I need to until I can get this, I can run this experiment, this feature toggle to see does this need to be a permanent change to my database. If not, I can just roll this change back and undo it and undo the feature toggle. If it is going to be a permanent change, then I go to the ending state and go ahead and fix up B and C and fix up A and manage all this stuff. And so you can, in fact, do feature toggles using databases, using some of the techniques from the Refactoring Databases book. Okay, so did I answer all these questions? Let's see and make sure. I answered the measure for determining if 2 developers on trunk are working in a discontinuous fashion without interfering with one another. You actually want them to interfere with each other if they both touch the same source file at the same time. It's okay if they do that underneath a feature toggle, but you actually want them to, if both of them touch the customer file, you want that. The faster you get the merge conflict, the less you have to merge between the 2 changes. So you actually want them to bump into and interfere with each other. There's a question here from GB, where's the state for feature flags maintained? This is especially challenging in cloud configuring environments. It's a great question. This really depends on what scope can everything see. So a lot of feature toggles are created locally within the application, just as a name value pair map, for example. But I've also seen teams use tools like Apache Zookeeper or any sort of asset management tool like Vault or Zookeeper or anything like that can absolutely be a store for feature toggles as well. These can also be in a database. There's nothing at all wrong with putting feature toggles in a database and just accessing the database to get to those things. That's another good place for them to be maintained. It's really just which place has visibility to all the places that I might need to see those feature toggles. CK says trunk-based development seems great until you need to support multiple concurrent releases. That is a way to do it at the release branch level, but it depends on how concurrent those are and how much they rely on one another's changes. So if you are trying to converge on a single code base but have concurrent releases, then release feature toggles is going to be way easier than release branches to do that, because the release branches are constantly having to merge and reconcile those things because you're trying to get to a cohesive code base, whereas you're more naturally moving to that space using feature toggles, because now you're just removing feature toggles to cohere onto that code base, not doing all this merging from side to side. You can't build a simulated internet at scale. That's true. Scopes, I mentioned that. Can ToggleZ or other tools detect the dependent feature toggle instantly? Well, the way that ToggleZ does this is it sets up for example, for a web application, it sets up a servlet that all the requests go through, and so it evaluates the state of the toggle in real time in that case, so that you look at, so for example, for the QA in production issue, it looks in real time to see, what IP address you have and whether that flag should be turned on or not. Of course, that can have performance issues. In fact, GB exactly asked this question. You got to be careful about latency issue or performance, et cetera. You don't want to do too many things at one time. So you have to tiptoe around that. But again, this is not that different from trying to do the same kind of stuff using something like branches. There's a question here that has been lurking for a long time, so thank you very much for your patience, YF. I have not forgotten about you. This one is long enough. I'm going to use my magic power as a presenter to actually push this out to the slide area. Here is the question from a while ago. As a security architect, what should be the best engineering practice one should follow that we have shift-left approach in secure development lifecycle, addressing security risks, design phase, and review the threats, defining security requirements, et cetera, how to integrate that into CI/CD? Fantastic question. And this is exactly that shift-left approach. Move it closer to development in the deployment pipeline versus closer to production. And that's exactly what you want to do. Between the time that YF posed that question and the time that I've answered it, we talked about this idea of architectural fitness functions, and that's exactly how you shift a lot of these security concerns to the left, is by doing creating security checks and then wiring those into your continuous deployment pipeline. In fact, I'll talk about two scenarios there since you asked that specific question. One is around holistic governance. I said earlier that most fitness functions are local, but there are some that are that can be global. In fact, let me go to this picture. This is a convenient picture. So imagine this deployment pipeline for just a second. And here's a question for you outside this deployment pipeline. What does your company do right now for a zero-day exploit for one of the libraries or frameworks you were using for development? This is unfortunately not an abstract question. This is exactly what happened to Equifax, a big financial reporting company here in the U.S. back in 2017. there was a zero-day exploit for a particular version of struts, and they found out about this. So what did they do? Their security experts ran around the company trying to find affected versions of software that was using that version of struts. And they found most of them. Most of them, not all of them. Ones they didn't find are still dealing with the repercussions of the largest data breach in U.S. history. Imagine a world for just a second where your security team has a slot in your deployment pipeline for every project that you're working on. And probably the only thing they do on a regular basis is check to make sure you're not checking passwords into version control or other bad things like that. But the day that zero-day exploit comes out, they can insert a test into everyone's deployment pipeline that says, if you're using this version of this software, fail your build, notify the security team. Now, this is becoming that much more important with the Cloudflare problem and the Log4j issue. Software supply chain is becoming a big deal in a lot of organizations. And there are tools out there like, this has actually been incorporated into GitHub now, Dependabot, and there's a whole class of tools now like SNCC, which look at software supply chain. What is the bill of materials for this piece of software so that I can do a quick security check to see if I'm using something that needs to be addressed from a security concern. That's one way to use, to shift left for that kind of security, is to add that kind of stuff into your deployment pipeline and make it so that you can automate more and more of those kinds of security checks. This goes back to this idea of automating architectural governance is a part of what you want to be able to do there. And so being able to wire that into CI and CD is a nice thing. Okay, so let's talk about one last thing here, which addresses the fear that I talked about earlier and this incremental change business that I was talking about before. So let's say that you have a website that has a shopping site. This is modeled under a widget shopping site in our Evolution Architecture book. And there's a star rating service that allows you to rate which products you like best, which clerks you like best, which shipping styles you like best. So there's a star rating service running in the architecture. But then one day we release a better version of star ratings that allows half-star ratings, and we put it live. We don't force anyone to start using it. This is just now a new capability that exists in our ecosystem. And over time, services that need star ratings are going to evolve to this better star rating service because it gives you better star ratings. Until eventually no one is pointing to the old star rating service anymore. One of the tricks that Netflix taught us about ecosystems like this is you monitor not only the services, but also the routes between services. And when you find a service no one is routing to anymore, you disintegrate that out of your ecosystem. In fact, we've already seen the monkey that does that. It's the the janitor monkey. The janitor monkey. That's exactly his job in the Netflix ecosystem, is to find services that we have evolved beyond and disintegrate them out of your ecosystem. So that's it in the abstract. Let's talk about a case study that ties together a whole bunch of the things that I've been talking about. This is from the GitHub engineering blog, an entry called Move Fast and Fix Things. As I mentioned before, GitHub is a very aggressive, agile engineering organization. They do continuous deployment. They average 60 deploys a day, and they also operate at really high scale. In fact, one of these engineers said that one of the interesting things about working at GitHub is that they operate at such scale that every edge case appears almost instantaneously for them. And this is about their need to replace the way they merged things. Because it turns out since day one at GitHub, the way they merge two files is to shell out to a shell script, tell command line get to merge it, and then suck it back into GitHub, which works great. It just doesn't scale particularly well. And so now they've decided we need to write our own in-memory version of merge, which they did, and they did the testing against the Git spec. But now here comes the scariest part of my whole talk. Now they have to put it live. But here's the problem. You can't break merge at GitHub. It's literally never had a bug logged against it. The last thing you want on some random Tuesday afternoon is bugs to start showing up in merge. But that's not even the real fear. The real fear is you update merge and it works perfectly, but break something way over there that you didn't even think was connected to merge. And then you have to do this forensics. Oh, that was, and then that, okay, that's the fear that everybody has, or the rippling side effects. Not even the primary effects, the secondary effects that people fear. The way that GitHub overcame that and open sourced it so you can take advantage of it is to create this tool called Scientist. Scientist is a library that's originally written in Ruby. It's been ported to a dozen other languages now. It'll let you conduct experiments at the architecture level. Scientist includes experiment blocks which have two clauses, use and try. Use is the old code we're replacing, and try is the brand new code we're trying out. So when it hits one of these experiment blocks, it always executes use, and that's what it always returns to the user. Your user never gets a surprise result. They always get what they were expecting, from just like in the old code. Excuse me. But you can also set a threshold for how often and whether to run the try block or not. So for the merge experiment, they ran the try block for 1% of the cases. And when that happens, it randomizes the order in which use and try are run so you don't get any weird timing issues, measures the duration of everything, compares the result of try to the result of use, swallows and records any exceptions, and then publishes all this to a dashboard. This is what the initial rollout looked at. So around 220, they're doing a little over 2,000 merges. If you look at the bottom, you can see some tiny red tick marks, but they're so small they're hard to see. So let's magnify the bottom. Here are bugs in their new code. But this hasn't impacted their users yet because this is underneath Scientists, so it's swallowing all these changes. And now they can go in and fix it, redeploy it, fix it and redeploy. So they're redeploying their code along with everybody else redeploying their code. Here's the performance profile. The green is the new code and the blue is the old. So the new code is performing a lot better, which is again what they would hope. They ended up running this experiment for 4 days until they had 24 hours with no mismatches or slow cases, removed the old code, left the new code in place. Over the course of those 4 days, they did more than 10 million comparisons between old and new until they had really high confidence that new code was doing exactly what they wanted it to do. But really all this is, at the end of the day, all Scientist really is a feature toggle framework with metrics built into it. And a combined fitness function, the janitor monkey, allows you to do continuous deployment but mitigate the risk of doing that because you're executing that stuff behind the scenes to make sure you haven't broken anything until you have enough confidence to actually turn it on for real. This allows you to run things in the background and verify them as long as you need to. And so using a tool like Scientist, we're doing a lot of mainframe migrations from the mainframe to a modern system. For each discrete function that the mainframe used to do, we're building a Scientist-like check to make sure that the new code and the old code produce exactly the same results as a way of building a fitness function. So, architecture for continuous delivery is really about good engineering practices and appropriate structure, keeping coupling down, keeping communication to a small scope, not letting things, implementation details spread throughout your architecture. And this really helps you apply good engineering practices to architecture, because these engineering practices help you validate the important parts of your architecture to make sure that things haven't broken as you make incremental changes to it. And it gives you the ability to move really quickly without breaking things and do continuous delivery or all the way up to continuous deployment. All right. Well, that's the last of my class today. Thank you very much for attending. Fantastic audience. Lots of really, really great questions, which is always